Hello. Today we are starting a new unit all about polynomials. The first half is going to be talking about what polynomials are and how do we add, subtract, and multiply them. And then the second half of the unit is going to be all about factoring polynomials. And so we're separating that into its own unit. So this first half is just going to be what are polynomials and how do you add, subtract, and multiply them. So today we're going to get started with some new vocabulary. So we first need to know what a term is. A term is a number, a variable, or a product of numbers and variables. So it's a number, a variable, or a product of numbers and variables. So for instance, an example of a term would be something like 3x squared or negative 2xy z to the fourth. Something like that. Those are separate terms. A monomial is something that is exactly one term, meaning you cannot see addition or subtraction in the problem. It is just one term by itself. A binomial is going to then be two terms. So you'll see something like x plus y or 2y minus 3, something like that. Those are both binomials because each of these separate parts represents one term and there's only two of them. A trinomial, think of that prefix tri means three. So a trinomial means that something has three terms. So there are three separate parts to it, separated by addition or subtraction. And the last one here is a polynomial. So a polynomial is going to be a monomial or sum of monomials. So everything above here, monomial, binomial, and trinomials, they are all specific ways of naming polynomials. So if something's a monomial, it's automatically a polynomial. But polynomial is going to be the name that we use for anything that has four or more terms. We don't have a specific name for it if it has four or more terms, unlike 1, 2, and 3 terms. Now we need to know what a polynomial is. We also need to know what some things that make something not a polynomial. So for instance, something is not a polynomial if it has negative exponents. So polynomials can't have negative exponents. They also cannot have variables in the denominator. So examples of these ones would be like if you have 1 over x squared, this is not a polynomial because it breaks the variables in the denominator rule. Or even if you have x to the negative second, this is not a polynomial because you can't have negative exponents. In short, exponents have to be whole numbers. So you cannot have, for instance, x to the y or x to the 1/2. These are not polynomials because the exponents are not whole numbers. So let's take a look at a couple examples here. So 1 through 6 here, we want to do two things. We want to first answer, is it a polynomial? So we're going to write yes or no. If it is, we want to determine the name of the polynomial. So is it a monomial, binomial, trinomial, or polynomial? So for the first one, you notice it's just an x. The exponent here is x to the first power. So it is going to be a polynomial because it's not breaking any of the rules. So we don't have negative exponents, there's no variables in the denominator, and the exponent is a whole number. And since we said yes, we have to figure out how many terms there are. So this one only has one term, and so therefore if it has one term, we call that a monomial. Again, prefix mono means one. So for number 2, first, is this a polynomial? So we look at each of these different terms and we ask ourselves, do we see any negative exponents? No. Do we see any fractions where the variable is in the denominator? No. Are all of our degrees a whole number? Yes. So this is a polynomial. Then identify it by its number of terms. This has 4 terms. So since we don't have something to classify it if it has 4 terms, we call that a polynomial. How about this next one? So we take a look at it and we ask ourselves, for each term here, do we see anything with negative exponents? No. Do we see anything with a variable in the denominator? And this first one here is breaking this rule. So no, this is not a polynomial because there are variables in the denominator. How about number 4 here? So we look at this and right away we see there's that negative exponent and that a. This means it is not a polynomial because we have a negative exponent. We also have an exponent that is not a whole number. And since these are not polynomials, we cannot classify them based off of the number of terms. So 2 more examples here. We have 3 to the x. This we're used to seeing. That was our whole last unit. This is an exponential. So this one here is not going to be a polynomial because the x is the exponent. And that breaks our rule because our exponents have to be whole numbers. Looking at number 6, every single term, the exponents are whole numbers. There's no fractions, there's no negatives, there's no term that has a variable in the denominator. So yes, this is a polynomial. And there are 3 separate terms here, which means this one is going to be called a trinomial. So let's go ahead and take a look at monomials. So looking at each of these here, you notice each of these has one term grouped all together. There's no adding or subtracting. So each of these represents a monomial. To find the degree, what we're going to do is we're going to take the sum of the exponents of all of its variables. What this is really saying is how many variables are there? So looking at this, we have the 32 and we have the x squared. The x squared means that there are 2 x's there. So the highest degree here, or the degree of this one, would be 2. There are 2 x's being multiplied. Whereas the next one, if I ask you how many variables are there, you're looking at that and well, there's none. So for this one, the degree is 0. And the reason being, if we had for something like x to the 0 power, the degree is talking about your exponent. So anything to the 0 power would actually be gone, and you'd just be left with the constant. So this one here, the degree is 0. So for this next one, we're asking how many variables are there? And looking at this, what's happening is there are 3 x's and there are 4 y's. So overall, the degree here would show that there are 7 variables in this monomial. So we're taking our exponents and adding them together. So for this next one here, I have 2 a's, I have b, but there's technically a 1 there. So there's 1 b and 7 c's. So overall, the degree would state that there are 10 variables in this monomial. So it's a degree of 10. So we need to be able to determine the degree of a monomial to then determine the degree of the polynomial. So we want to, for the degree of the polynomial, find the degree of each term. So find each term's degree, and then you want to find the biggest one out of those ones. Okay, so first what I'm going to do is I'm going to look at this first one. This is a monomial. So all of this is one term because there's no adding. 1, 2 x's, has a degree of 6. And since this is the only term in the problem, that's just our degree. That's it. Whereas for B, you have to be careful. You're first going to find the degree of the first one. Then you're going to find the degree of the second one, and we're going to figure out which one has a higher number. So for this 3x's and 2y's, overall there's 5 variables in that part. For the next one, we have 1x and 3y's, so overall there's 4 in that one. So now to find our overall degree, we look for which one is the biggest. So this one, the most variables in one part of it is 5. So the overall degree of this polynomial is 5. So let's try this next one. This first one, it has a degree of 4. My next term has a degree of 2 because it's x to the second. My third one, there's no variables, so it has a degree of 0. So I find each term, and then I find the highest one there. So the degree of the highest term is 4. And then for part D, one more problem. There are 2 separate terms, so I analyze those separately. The first one has one variable, it's b to the first power. The next one, b to the first and c to the second, I can take and add, and there's 3 different variables in that one. So my highest number here is 3. So overall, my degree is 3. Once we can identify the highest degree, then what we can do is we can start naming them. So if something has a degree of 0, that's going to be called a constant. If something has a degree of 1, that's going to be called a linear function. If something has a degree of 2, that's going to be called quadratic. 3 would be called cubic. 4 would be quartic. And 5 would be quintic. So we find the highest degree, and then we can call something a quadratic if the highest degree is 2, or quartic if the highest degree is 3. Nope, 4. Anything that's higher than 5, you're just going to say it's a 6th degree or a 7th degree. And this first example here is a perfect one for that. So I have 1x, 5y's, 2z's, so overall I have 8. Since this is just one term, this is going to be an 8th degree polynomial. For the next one, I look term by term. We have a degree of 2, a degree of 1, and a degree of 0. So my highest degree is 2. So therefore, if it's a degree of 2, that means this would be called a quadratic. For the next one, again, I have 4 terms here. The first one here has 1r and 1t, so overall 2 variables. The next term has 1r and 2t, 3 variables. 2 and 2 would make a degree of 4. And my last term has 0 variables. So looking at all of these, then the highest number here is 4. And since my highest degree is 4, that's the overall degree of the polynomial, meaning this would be a quartic polynomial. Once you can identify the highest degrees, you're going to write them in standard form. So standard form is the greatest to least. So you find the highest degree, which is 4x to the 4th, and that comes first. Then the next one would be the x squared, because that's the next highest degree. The next one would be the negative 3x, and then the plus 8. The leading coefficient is the number out in front after you rewrite it in standard form. So the leading coefficient is going to be 4 for this one. For the next one, my highest degree is 6. Then comes 5y to the 3rd. Then negative 2y squared, and y, and 10. And so my leading coefficient for this one is going to be negative 7. So standard form, highest to lowest with your degrees. For the word problem, you can go ahead and put your answer against what I have. Thank you very very much for listening. I hope this helped and we can see you tomorrow.